Okay, inequalities. We have 20 and 10. I want you to put the inequality sign. Remember, inequality is greater than, less than. Okay. Now, the sign has to eat or open towards the bigger number, so go that way. Now we're going to run a couple of some experience. We're going to add 3 to each number. So that'd be 23, that'd be 13. Now, well, the sign would eat the 23, and there's no change. It's still a greater than sign. So there wasn't a change from here to here when I added. So when you add, there's not going to be a change of the sign. Now subtract 3 from each number. You're going to get 17 and 7. 17 is bigger, it eats a 17. Okay, so again, the sign doesn't change when you subtract. Now divide each number by 5. So if I divide 20 by 5, I get 4. If I divide 10 by 5, I get 2. So it would eat the 4. So it's still a greater than sign. Now divide each number by -5. So 20 divided by -5 would make -4 instead of 4. And then you'd have -2. Now -2 is a bigger number, so eats a -2. Now it's a less than sign, so the sign flipped. Okay, it flips when you divide by a negative number. Now multiply each number by 2, so that's going to be 40 and that's going to be 20. Eats 40. Okay, so there's no change when you multiply by a positive. But when you multiply by a negative, you're going to get the similar situation. Instead of 40 and 20, you're going to have -40 and -20. And now -20 is bigger. So now it eats a bigger number, so the sign switches. -40 is less than -20. Now, what we're doing today on today's assignment is we are solving inequalities. You solve them very similar to equations, but you have to be more careful. Okay. So when you solve an equation like with an equal sign, you're just finding the one answer for x. But when you solve inequalities with less than and greater than signs, x can be a whole bunch of different answers. Okay, so you represent your answer with a number line. I don't care where you put it. You can put it up above and 0, and then we have to find the number where the x solution starts at. Okay. To find that one number, what you do is solve it like an equation. So x is on this side of the inequality. You have -6, which is plus -6. So we take out the -6 by adding 6. Now when you add and subtract, you don't change the sign. So I'm going to put keep sign. So before I add the 6, I know that I have to keep the sign the same. So I add 6, I add 6. So you have x. The -12 plus 6 is -6. So we have x is less than or equal to -6. Okay. So the solutions for this problem start at the -6, and you close the circle because you can be equal to -6, and x can be anything less than -6. Okay. So we'll go this way. Now, as I've illustrated, okay, pick a number that goes that way. Okay. Picking -6 just makes one side equal the other. Now pick a number that way. Let's pick -8. So x plus -6 less than or equal to -12. So I'll put -8 in. I can put any number as that way. Okay, so I add these together, and that's -14 less than or equal to -12, and it eats the bigger number just like it should. So any number that way will end up eating the bigger number, which means it's true. It's yes. Okay. Okay, and I'm not going to do that for all the problems. It takes too long. Okay. All right, so the next one, we represent answers for inequality using a number line because there's an infinite number of answers. So the number line is the only way you can represent it. So -3 is greater than x minus 7. So this time we're over here, plus negative, and we have to get the x by itself. So the -7, we add 7. And again, when you're adding and minusing, adding and subtracting, you keep the sign the same. Keep sign. So I keep the same sign for now. So I add 7, add 7. -3 plus 7, is 4. And then you have x. Now, don't graph that. It's not actually greater than. See up here, you have to have the variable. Remember, the number line represents the answers for my variable. okay? In order to graph out an inequality, we have to reorder this so that the variable comes before the 4. Well, I can accomplish that as long as I flip the sign. So x is less than 4. Okay. So 4, now I don't close, I leave the open circle, and it's less than 4. Now there's a couple things I want you to, there's one thing I want you to do above this. Can you copy this on top of your little number line, please? Okay. And same here. And I want you doing that on the assignment. Okay, next one, x plus 0.7 is greater than or equal to negative 3.5. So x is over here. And again, we're going to want a number line. You can use a number line with decimals too, okay? So we have to minus the 0.7. Now, if you remember from the previous page, when we minus, the sign didn't switch, so I'm going to keep the sign. So I keep the sign the same. And then minus 0.7, minus 0.7. Negative 3.5 minus 0.7 is negative 4.2. Okay, so the solutions start at negative 4.2. If you put 4.2 in, it equals the other side, so it's a closed circle, and then greater than. So not only can it be equal to this, it can be any number greater than that. Now copy that, x greater than or equal to negative 4.2. Okay, next problem. We have negative 2x greater than or equal to 14. So x is over here. Now, this is multiplication, so you want to circle that again. I haven't been circling because I never had multiplication or division. Now I do. So we're going to divide by negative 2. Now, when you divide or multiply, if it's going to be by a negative on both sides, with this, which this one is, you are going to switch the sign. Okay, so I switch the sign, then I divide by the negative 2. Now, if I'm dividing by a positive, I don't switch the sign. Okay, and that's good. X is less than or equal to negative 7. So 0, negative 7. Circle, fill it, close it. You can be equal in anything less than negative 7. Okay, next problem. Negative 5x less than or equal to 10. So number line real quick. Here's the x, negative 5 times x. So we're going to need to divide by negative 5, and when I divide by a negative, we switch the sign. So switch the sign and then divide by negative 5. So we have x. 10 divided by negative 5 is negative 2. So x is greater than or equal to negative 2. Circle, close it. It's greater than, so it would go this way. Okay, so so it's equal to negative 2, and then anything going that way makes it the correct solution. Okay, 18 less than negative. Now, again, I'm going to show you how you can check your answer, whether you have it going the right direction. Pick a number after negative 2 this way. Let's go with positive 2. So negative 5 times x, I'm going to write the original problem, and I'll put positive 2 in for it. Negative 5 times 2 less than or equal to 10. So I multiply that. That's negative 10. Well, 10's bigger than negative 10. It eats the right number. So I know I have the graph going the right way. Okay, next problem. X is on this side, negative 9 times x. Please circle the times, and that means we need to divide, okay, by a negative number once again. So we switch the sign. Now, if you're dividing by positive, you would keep the sign. But if you divide by a negative, you switch it. So it's negative 2, and you get x. Guys, do not graph greater than. Remember, the graph represents x, so we put x first, then we reorder the solution, okay? Which you can do as long as you switch the sign. So we have negative 2, we circle, we leave it open, and then less than, okay? And just put that above it. Okay, next problem. X divided by 4 is less than or equal to 5, okay? So I have division. I'm going to circle division just like I would with multiplication. I don't know why I drew the number line there. It doesn't really matter. Okay. So we have to do the opposite of divide by 5, which is times, or divide by 4, which is times 4. Now when you times, if you timesing by a negative, okay, you're going to flip the sign. If you're timesing by a positive, you're not. So 4 is positive, okay, so I keep the sign. Okay, on multiplying and dividing, if you're dividing both sides by a positive, you keep the sign. Negative, you switch the sign. Okay, and also I don't care about the number over here. It's all about this number that I'm doing to both sides. Okay, so we're keeping the sign. If that was a negative 4, I would switch the sign. Okay, so keep it times 4, gets rid of the divide by 4 times 4. So you have x, 5 times 4 is 20. Okay, so we have 20, we close the circle, and it's less than, so it can be 20 or anything less. Okay, next one, we have the fraction negative 2x is over here. Negative 2/3 times x plus 4 is less than 18. Now, I need to minus the 4, and then I need to divide by negative 2/3. Now, when I plus and minus, the sign doesn't change. We keep the sign on that step. But then when I go to divide, it's going to be by a negative right there, so we will switch the sign on that step. Okay? So keep the sign first, minus 4, and that's going to be 14. Then when I go to divide, I'll be dividing each side by negative. Remember, I don't care about that one. It's all about this one, okay? So, because that's the number I have to divide both sides by. Or I'm not dividing both sides by 14. I'm dividing both sides by negative 2/3. So x, negative 21. Basically, to make a long story short, okay, when you multiply or divide both sides by a negative, the sign needs to switch. Okay, and also it switches if you have to reorder at the end, which we don't have to do. X comes first. So you have negative 21, circle open, x is greater, anything greater than negative 21. Okay. Okay. 5x plus 7 less than or equal to 22. Okay, so number line. Remember, x has an infinite number of possible solutions. You just put it on a number line. So 5 times x plus 7 less than or equal to 22. So I like to circle the times. So I know I have to minus 7. And then I'll have to divide by 5. Now when I plus and minus, we keep the sign. Then when I divide, I'm dividing by a positive here. So I will keep the sign there too. Okay. Positive 5, so we keep the sign. Remember on the first page when you divided by a positive, okay, on both sides the sign didn't switch. So minus 7, sign never flips when you plus or minus. And then 15. Then when I'm dividing this time I keep the sign because I'm dividing by a positive. So x, 15 divided by 5 is 3. So this, and that's in the correct order. Remember we need the x to come first. And it's less than, okay? There we go. X can be 3 or any number less. Okay, this one, we have a parenthesis. So we need to apply the distributive property, okay? When you apply the distributive property, you keep the sign, okay? You don't never switch the sign on the distributive property. So I make that plus negative. You can put a 1 in front of the x if you want, but you need the plus negative. So negative 3 times x is negative 3x. Then negative 3 times negative 5 is 15. Then on the other side we have negative 3. Okay, now over here we got the times there and the plus. So we're going to have to minus 15. And then divide both sides by the negative 3 right there. So minus, so it's always keep the sign. Dividing by a negative, we switch the sign on that step. Okay, so when I'm minus 15, I'm not switching the sign. Okay, so negative 3 times x. Negative 3 minus 15 is negative 18. Then when I go to divide, I'm switching the sign because I'm dividing by a negative. Had that been positive 3 right there, I would not be switching the sign. So we have x and then 6. Okay, so the solution set starts with 6. You circle, you're going to close it. And then it's less than, so the x would be anything less than 6. Okay, F's the letter instead of X, who cares? Okay, it's the same thing. Now you have like terms of F, okay, so like terms I'm going to put. When you're dealing with like terms, you always keep the sign, okay, because that's not a division or multiplication thing. 5F and 6F. Now you might say, oh, take out the smaller one, but if I do that, there's not going to be anything there, okay? So this is a one instance where I will take out the bigger one. It's positive, so we will minus 6F. Remember, we're keeping the sign the same when we do that. So that's going to be negative 1F, and then we have the negative 6. So now I have the like terms taken care of. F is over there with times negative 1. So all I have to do on this one is divide by negative 1. Now I'm dividing by a negative, so I will switch the sign, okay? So divide by negative 1, divide by negative 1, sign switches. F, negative 6 divided by negative 1, 6. So you have 6, you circle, you will close it, and less than 6. Okay. Okay, next one, 6 minus 3x less than or equal to 4 minus x. Again, we have like terms of the variable. Okay, that is always a sign keeper when you're combining the like terms of the variable. And they're not combining because they're on opposite sides. So I have a negative 3x and a negative 1x. Okay, again, usually take out the smaller one. So I'll add 3x. Add 3x. Sign's not going to change when doing this. Okay, and then 4, and then negative 1 plus 3 is 2x, or you can write 2x plus 4, so x is over here. Okay, so we're going to have to minus 4, and then divide by 2. Okay, minus 4, that's always keep sign when you plus and minus. Now when I go to divide, I'll be dividing by positive, so that is a keeps the sign. I don't care about this number, it's right here. When I minus a 4, the sign won't change. When I divide, it'll be by 2, so that's positive. Minus 4, we have 2, and then 2 times x. You don't need the plus there anymore. Now I go to divide. Sign's not changing because I'm dividing this by positive 2. So that's 1 and then x. Now, don't do the number line until the x is before the 1. So x1, you have to reorder that. So instead of less than, it's going to be greater than or equal to 1. So again, don't do the number line until x comes first. And if you have to reorder it, you flip the sign. Circle, close it. Now it's greater than 1. Because if 1 is less than x and x is greater than 1, that's how that works. Okay. Now if you're wondering why haven't we had to reorder it before, because it's just an equals. Okay, equals the order doesn't matter, but greater than less than it does. All right. Okay, we have to distribute distributive property. So number line. So negative 2 times 6, negative 2 times 1x. You always, when you're doing the distributive property, that's always a sign keeper. Keep sign the same. So negative 12, negative 2 times 1x is negative 2x. Then over on the other side we have negative 15 minus 2x. Now, we have like terms, okay, of x, but they're exactly the same. So when they're exactly the same, you get rid of them both. Now you don't need this number line. So that is going to be all solutions or no solution. Now, you don't just go by whether the numbers are the same now. If it eats the correct, circle the bigger number. Negative 12 is bigger. Does it eat that? Yes, so that's all solutions. Okay, next problem. Okay, like terms, you don't have to distribute, but we have 2x and 2x, so that's like terms of the variable. Okay, this like terms is always keep sign, because that's, I'm not dividing or multiplying here. 2x and 2x, they're the same. Now, that's all solutions or no solutions. Okay, okay, 9 and 1, well, 9's a bigger number, but it's eating the wrong number, okay? So that is a no solution. And then we don't need the number line on all solution, no solution. You can't graph that. Okay, we have to do the distributive property here. That's always a sign keeper. Keep sign. Know that. So 2 times x plus negative 8. So 2 times x, 2 times negative 8. 2x plus negative 16. And over here we have 16 plus 2x. And we have like terms of the variable. Okay. 2x, 2x. You get to cross them both out. So it's all solutions or no solution. So I have a negative 16, a positive 16. Well, this is my bigger value and it's eating the correct value, so that's all solutions. Okay, then finally, and so number line not needed. 2 times 3x, 2 times, that's a horrible looking 6, okay. So distributive property, you need to keep the sign when you distribute. And the reason why I keep the sign, you're like, if that was a negative, would I flip it? No, because you're not doing it to both sides, okay. So it'd be 6x plus 12, and over here we have 6x minus 4. And we have like terms. Like terms is always keep the sign, but it's not really going to matter on this one, given that they're the same on opposite sides. Okay. Okay, so it's all solutions or no solutions. Okay, negative 4, positive 12. Well, positive 12 is obviously bigger, eats a bigger number, you bet. That's all solutions.